So, Assalamualaikum and a very good morning to Dr. Nur Fazilah. So, I am from Group 4, Computer Programming. So, my name is Wan Muhammad Shakib bin Wan Muhammad Hanapi. My matric number is AD190016. So, my group members is Nur Ashikin binti Muhammad Yusof. Matric number AD190057. Muhammad Amir Izwan bin Sahari, matric number AD190041. Muhammad Ikmal bin Ismail, matric number AD190181. Muhammad Zainuddin bin Yusli, matric number AD19081.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal bin Ismail. Now I would like to talk about the part of the machine specification. First of all, this is a LED machine. There is a headstock, a chuck, a tool post, compound rest, tailstock, bed, lead screw, carriage, and feed shaft. These are all the main parts in a LED machine. Next is a milling machine. We start from the motor, then to the ram, column, table power feed, vertical positioning screw, base, vertical knee, transverse crank, knee, cross feed handle, table transverse crank handle, table, spindle, and the head. Next is the drilling machine. We start from the hand wheel, then there is an electric motor, column, there's the table clamp, the base, the drill, and the chuck. Okay, these are the part that we design using the lathe machine. This is a cylindrical object. Then for the milling machine, we gonna make the angle or the edges from the object. Then the drilling machine is where we do the hole at the object. Next is the operation analysis for the machines. First of all, the lathe machine. Lathe machine is a machine that rotates the piece on the axis in order to perform various operations like cutting, facing, milling, deformation, and more. It's also metal spinning, thermal spraying, wood turning, and metal working are the common operations performed with a lathe machine. Lathe machine is used to remove metals from workpiece to give a desired shape and size. It removes the metal in the form of chips from a piece of work by mounting the same rigidly on a machine spindle and revolving at different speed. The cutting tool is against the work longitudinally of crosswise to make the work to the required shape and size. Next is the milling machine. Milling machine is a machine tool that cuts metal as the workpiece is fed against a rotation multi-point cutter. The milling cutter rotates at a very high speed because of the multiple cutting edges. It cuts the metal at a very fast rate. It can create edges on objects and smoothen the rough surface of objects. This machine can also hold single or multiple cutters at the same time. Next is a drilling machine. Drilling machine is an application for cutting holes in and out of metals. A material removing or cutting process in which the tool uses drill bit to cut a hole of circular cross section in a solid materials. The operation occurs by rotating and pressing a multi-point drill bit. To cut a hole, the drill bit is rotated at a very high RPM. That's all for me. Thank you.
Assalamualaikum. My name is Muhammad Zainuddin bin Yusli. My matrix number AD190081. I will explain about lathe machine. First, algorithm. Algorithm. Algorithm is a flowchart. We start from start, then try turning to make turn to make sure the position of workpiece. And if the workpiece is turned in bad condition, we go to the error, which is we should stop the machine. Then if the workpiece in good condition turning, we input the X position. Next, angle cut. If angle cut, if the workpiece have angle cut, we input the angle cut, the angle of cut. If we don't have the angle cut, we just input the depth of cut. After we put the angle of cut in the program, we input the depth of cut. After that, we input the distance of cut. After that, we start the cut until it finish the step. After finish, we stop the machine and in. Second, pseudocode. Pseudocode is about how the program works. First, put the workpiece at the spindle and then start the machine. If the workpiece is turning in good condition, continue to the next step, and if the workpiece turn in bad condition, it will stop immediately. Third, enter the position of axis position. It depends on its start cutting position. Fourth, enter the angle value of it. It has the angle cutting step. If it does not have the angle cutting, proceed to the next step. Fifth, enter the value of depth of the cut, which is the depth is y-axis position. Sixth, enter the stop cutting position, so the cutter will stop when it reaches the stop cutting position. Lastly, the cutting process will start until it finish. Okay, C++ coding. This is my C++ coding. C++ Next, output. This is my output. This is without angle, and this is with angle. That's all from me. Thank you.
My name is Nashiki binti Muhammad Yusof, IT1900057. I would like to present about milling machine. For the selected material, first mild steel sheet, next square shape and have 4 holes. The types of carbon steel which a low amount of carbon, which is actually also known as carbon steel. For the flowchart, first start. Next, welcome to Alpha milling machine, and we enter the part of machine. Specific speed, material size, cutting speed, and so on. Next, enter the value of parameter. Then, if C is less than 2, we go to yes and start the process of milling. If no, then we try the value of C less than 3 and 7. If no, then it was invalid value. So, this is my code in C++ programming for milling machine. I use this code to produce the process of milling. Here are the output that we can get from the input based on coding. So let's try the output.
So here are the output for milling machine. For the length, we choose measurement 800 mm, width 200 mm, thickness 3 mm, Radius of hole 10 mm. Hole to hole distance 10 mm. Distance hole to edge 50 meter. So here are the output that we can get from my coding. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Izwan, and today I would like to present about drilling machine. Okay, for pseudocode, number 1, start. Number 2, welcome to drilling machine. Number 3, enter the parameter value. Number 4 is drilling speed C less than equal to. If no, then number 5 is drilling speed C less than equal 6. If no, then number 6 is drilling speed C less than equal 10. If no, then number 7, invalid value. If yes, then number 8, start the process of drilling. Number 9, end. Okay, the next one is flowchart. We're gonna start with start, input, length, width, depth, feet, diameter. And then C less than 2. If yes, go to calculation. If no, go to C less than equal to 6. If yes, go to calculation. If no, go to C less than equal 10. If yes, go to calculation. If no, invalid value. And then the calculation is N, which is rotational, equal to 100 divided by pi times C. F is feet rate, which is rotational times feet. T is time, equal to depth plus length divided by feet rate. MRR equal to pi times C times feet rate divided by 4. E equal to energy use, equal to MRR times 1200 watt. P is estimated product, 80 times 8. G is cost, P times 70 plus E times 70. Okay, the next one is the C codes. Okay, we go to the result. Machining time is the total time that we use to complete the object. Total energy consumption is the energy that we use the electric current. Estimated productivity per day is because is 0. Total operation cost is 65,000. Energy utilization 8 hours equal to 1.2 kilowatt. Okay, thank you. That's all from me. Assalamualaikum.
So for the conclusion, we can conclude that the program we just created actually can help the operators to solve the problem to determine the part machining time. So the total energy consumption, total operation cost, byproducts or solid waste generation, and estimated productivity per day. The operators only need to enter the diameter of the object and the feet rate. So this will make the operators to determine the part machining time, total energy consumption, total operation cost, byproducts or solid waste generation, and estimated productivity per day easily and most accurate. Thank you.